artificial intelligence will completely transform our world. But what is AI? Why will it affect you? And how can you and your business survive and thrive through the AI revolution? Welcome to AI and You. Here is your host, author, speaker, and futurist, Peter Scott.
Hello, this is episode 305. Rapid advances in AI, especially the shift from training to real-world inference, are reshaping work, business strategy, and the roles of humans in the workforce. They accelerate productivity while increasing cognitive demands on us and redefining where human judgment still matters. Here to help us get a handle on that and returning to the show after 5 years, yes, we've been going nearly 6 years at this point, is Rob May, co-founder and CEO of Neurometric AI, a pioneering company optimizing inference for multi-model AI systems. A serial entrepreneur, Rob has founded and scaled multiple successful companies, including Backupify, Tala, Dianthus, and BrandGuard. He's also an active angel investor with over 100 portfolio companies and brings first-hand insight into the evolution of AI entrepreneurship. His expertise lies at the intersection of AI research, applied inference, and startup strategy. He's also the co-host of the AI in NYC show, where he discusses the latest breakthroughs in AI infrastructure and reasoning with founders, investors, and researchers. We're going to talk about how the bottleneck in business is shifting from labor to cognition, the paradoxical way AI is increasing workloads and cognitive strain, the rise of inference as the core AI economy, and how infrastructure constraints are pushing towards a more distributed AI ecosystem. So let's get into the interview. Rob May, thank you for coming on AI and You. Last time we talked was February 2021 when you were at Tala. That seems like a lifetime ago now when you think about what has transpired. We could even frame dates in terms of before ChatGPT and after ChatGPT, just in terms of how much the world has pivoted, even though you and I obviously were talking about AI long before that impact on the world happened. When you compare those two times, like then, 2021, you have been working on AI in different capacities, and now, how do you compare the pace of the environment? I would like to say, well, which one do you prefer? But that's generally a no-brainer. Everyone would say, oh, yes, of course, I'd much rather be now. But those times are radically different in terms of the pressures that the world is placing upon people who have got anything to do with AI in their jobs. So how do you compare what that transition has been like, or what that time then was like to now?
Well, it is, AI goes through these step change functions that are discontinuous. And I think you've had several of those since we spoke last. Obviously, ChatGPT was one that suddenly, there were people like us that were talking and realized where this was going and what you could do with these models. But it wasn't until ChatGPT caught the collective consciousness that suddenly people were like, wow, and everybody started to think about it. So that was definitely one. And then I think the coding tools getting decent enough that they could make a dent in how fast people wrote code. So was that circa early 2024? I think that was a defining one. And then I think this Thanksgiving-ish timeframe release last year of Claude Code, I think that was another level of sophistication. As somebody who's technical, I'm a former engineer, but I haven't written production code in 17 or 18 years. I can do that again because I can have Claude fill in all the things that I don't understand or don't know. I can have another Claude agent double check itself, or a OpenAI or Gemini agent double check my code. And so it's really, really interesting, some of the things that have happened. I think over the next 10 to 12 years, you're going to see that happen to most industries, what's just happened to coding.
And how does the change in pace feel to you? What sort of pressures, what sort of speeding up of the hamster wheel? That might be a loaded question, but we're clearly in a different world with respect to the amount of money that's chasing anything with AI. in the name now. What does that feel like to you?
Well, it's interesting because I think when I was younger, in the 80s and 90s, I think you made more money by working more and you got more done by working more. Putting in another hour, even on cognitive tasks, another hour or two of analysis could really make a big difference. And then as these tools got better, as we got more software and everything else, it mattered how much you worked, but it more mattered how much you knew and what you could get access to and what you could connect to. So it started to be less about how hard you work at the direct task that you're doing and more how you think about the networks that you build and the information and people and companies and things that you have access to. And I think that's about to jump to another level where the bottleneck now, as of early 2026, when we're shooting this podcast, is how fast you can think. I build apps almost every weekend now for fun. Little things I'd like to use, some things I think about launching as tools. I recently built a chatbot for the city of New York, newyorkgpt.com. Pushed it out half day, super fun. But the problem you run into is, what do you want to build and what are the specifications, right? So now it becomes, well, do you want the flow to work this way or that way? And you have to make a decision. I mean, you could have the bot say, do it both ways, show me both. And you can definitely put that out on the bot. But I think what's going to happen is I think the cognitive complexity is going to start to strain a lot of people. So there's this concept that you learn in MBA school called economies of scale that most people know about, which is as things get bigger, it gets cheaper on a per unit basis to do, right? And you could do more things because you cover your fixed costs with more variable profit margins. There's a counter concept that's exists for a while that people don't talk about as much called diseconomies of scale, which is things get more difficult to manage as they become like sprawling empires are hard to manage, right? So why nobody runs the world and everybody who's ever tried sort of fails. And I think we're going to start to see more diseconomies of scale in our own lives. So diseconomies of scale are almost also like diseconomies of complexity, right? Which is the more things that you have to manage, the more you get confused, the more context switching. Human brains aren't great at that. I think you're going to see a lot of that. It's definitely that I work more because of these tools, not less, because I can do more now, right? Because I'm not waiting on information and all that. But I think I feel a little more cognitively drained than I normally do.
Well, there was a study out of UC Berkeley published in Harvard Business Review. Actually, it's a work in progress, but the researchers measured that people at the places they were looking at were working harder because of AI or more and not less. And the technology was driving them to do that. And that's a result of the choices that we make and the environment that we find ourselves in, which is what I was getting at the beginning of the show there with the fact that now AI is a mainstream thing with incredible amounts of money at stake and companies jockeying for a position at various leaderboards and insane kind of build-outs of data centers and that whole Jenga tower of power versus compute versus data center real estate and the loans that they're making. Would definitely not want to be in the middle of that. Feels like it's all going to come down the moment anyone makes a misstep. Being in business in that field, maybe we can talk about what it's like to have migrated from Tala to Neurometric as a serial entrepreneur, what that feels like for you now in today's world.
Well, one of the problems I've had in my entrepreneurial career is I think I've been too early on some things. I remember when I was doing my first company, which was called Backupify, we did backup for cloud computing applications, Google Apps, Salesforce. I started that in late 2008. And at that time, venture capitalists, believe it or not, would say, Rob, let me tell you something. Businesses are never going to move their data to the cloud. And if they do, they certainly don't. Yeah, they certainly don't need a backup and archiving system. And so we kind of struggled for a while until people had been on the cloud enough that they started accidentally having data loss and all this kind of stuff. And then, we built a really nice business. And then Tala was similar. We had the same idea as ChatGPT, but for customer support. But this was pre-large language model. We started Tala in 2017. And my co-founder Byron and I, our idea was you shouldn't have to script out the responses for the chatbot. It should just read the support documentation and be able to answer the questions. We didn't know that we needed 1,000 times more compute than we had to get that to happen. And so that was a little bit too early. Neurometric, I think the timing has been a little bit better. So the idea behind Neurometric and what I saw in the market that made me think about this was everybody was building their first AI apps on these frontier models, typically Anthropic or OpenAI, sometimes Gemini. sometimes others, Cohere, Mistral. But the people that were doing it at scale were starting to pay a lot of money and sometimes have latency problems. I mean, if you're going to, at the time we're recording this podcast again, because this might change, but like if you have a 12-step agentic workflow and those steps have to happen serially, and you're going to call Claude for every one of those, I mean, on a bad day on the API, you might have a 2.5-second wait on each of those. You might have a 30-second agentic workflow. And I started to realize with the advent of these reasoning models and test time compute and how test time compute can help smaller models perform as well as larger models, and smaller models run faster, they consume less memory, they're cheaper to run. I realized that some subset of agentic workflows are going to be run by small models. So why not be the company that leads that charge? So that's what we tried to do. And, when we started the company last year, we incorporated it like Thanksgiving 2024. And we were raising money in like spring of 25. And I mean, it was hard because VCs would be like, didn't Anthropic won? OpenAI won. It's game over. Of course, we thought that was stupid. And yeah, the world is starting to break our way now. And we've launched a product and have customers where we can evaluate models for people and say, for these workflows that you have, you should keep those on Anthropic, on Claude 4, 6, or whatever you're on. And for these, you should migrate to an open source model that's faster. For these, you should migrate to a small model. Maybe we can build you a small model that'll run in 100 milliseconds instead of 2 seconds. So we're having a lot of success, and I think that trend's going to continue. But man, I'll tell you, it is much harder conceptually to place bets on where the world's going than anything I've ever worked on. Every layer of the tech stack is changing right now. There's innovation all the way.
Of course, it's phenomenal. I'm reminded of a principle that if you're building products around services that someone else is providing, in this case, you're building products and services around models that come from other companies, that if you are going essentially sideways, I don't know the right way to phrase this, to what they're doing, then you've got a good business model. But if you're doing something that takes advantage of what they haven't thought of yet, you are fragile because they will look at what you've done and go, well, but we should do that. And then the next month, they've taken your lunch. Where do you feel that what you're doing stands on that axis?
Well, as a mission, we've set this goal of make intelligence free. So everything we do has the goal of driving down the cost, driving down the latency of running intelligent tasks and intelligent models. And so we try to stay out of the frontier model game and just benefit from that. And we try to build tools that help companies migrate between models, create their own small language models, manage, deploy, orchestrate those so that they can protect their IP. They don't have to send it to those people because, to your point, I think you get a couple things happening in the market. The model companies, the frontier labs, are moving super, super fast. And so the last thing you want to do is solve a problem where it's like, well, they only have a 1 million token context window. And to solve these problems, you really need a 5 million context window. So I'm going to build a tool that manages the context window for you. Like that's going to last 9 months until they have a 5 million token context window, right? So you don't want to do that. They're bad at medical diagnosis tasks. So we're going to, no. Again, unless you have something to add, your opportunity is there to add something around the workflow, around the user interface, around the connections that you have. I think you have to think about physical objects. I think you have to think about networks that you're building. I think you have to think about the attention that you have around distribution and usage, feedback loops from humans that you can connect with or whatever. Because like it would be hard for ChatGPT to go and sell itself into 3,000 hospitals across the United States. That would be just as hard for them as it is for you, right? You have to go hire somebody. They have to go do it. There's no way AI can help very much with that problem yet. So yeah, those are the things you have to pay attention to. I think you have to be really, really careful that you don't get your lunch eaten from the bottom. And so we try to stay around tools that help you build models, tools that help you manage between models, and things that are orthogonal to what the model companies are doing.
You've said that inference time compute is the next $1 trillion problem. Talk about that.
Well, if you think about all the money that's gone into AI so far, and this plays into the bubble rhetoric as well, it's all been focused on training. So you've got this pressure building up around training, and people spend more and more money on training, and it hasn't translated into inference yet, right? Which, inference time compute is this idea that the model's trained, it might still change a little bit. There might be some inference time training, but in general, you're interacting with the model, you're asking it stuff. And so that is the process by which these agents roll out. That process has not permeated the economy very much yet. But it makes sense that as more and more tasks become like, let's say, AI-ified, you're going to end up with a multi-trillion-dollar inference economy of models running and doing things for people. Right now, I don't know that the inference side of the economy is bigger than the training side of the economy, but it will be shortly if it's not. And it'll be 20 times bigger at scale. And so that will change a lot of the economics in terms of what people are looking at now, because we're judging the industry by the economics of lots of training and a little bit of inference. And they're going to look very, very different when the economics are like mostly inference. Now, they're not going to look like software because inference, harder tasks require you to think longer. So there is more marginal cost to inference than there is to running a SaaS application. So investors and entrepreneurs executives are going to have to adjust their mental models for that. But I think the economics in a couple of years are going to look much more favorable compared to the capital deployments than they look today.
Let's try and characterize this difference between inference and training in a way that's useful for people to think about. When chatbots were born, it was all in the training. They had been spending months absorbing 1 trillion words from the internet, and from that emerged intelligence, the ability to answer questions. And of course, it was restricted to what they had read. So if you asked them about a current event, they didn't know anything about that, or they lied. And that was quickly realized to be a great impediment. So we got retrieval augmented generation and other things that let them essentially be current much, much faster than was anticipated at the time, I would say too. So we have that now. So I think of training as being like the native competence of the model, and inference maybe as a skill, or what they're put to doing, the task level. I don't know that that's the most useful way of putting it, but I think we're talking about something here where it's useful to characterize this in a way for people to think about that difference succinctly.
Yeah. So the training process, I have this coffee mug here, right? And so the training process is I show a neural network a picture of this coffee mug and I ask it what it is. And it says, it's a water glass.
Yeah.
And I say, nope. So I take and I calculate the mathematical difference across all the neurons of the water glass and the coffee mug. And I push those backwards through the neural network and readjust the weights so that the next time it's a little closer and maybe it says it's a water mug or it's something closer, right? And you repeat this cycle for everything in your data set trillions of times. That's why it takes months and months and months. So that's how the training process works. But you're not actually doing anything, I don't want to use the word productive, but you're not doing anything useful to anybody yet. It's like the model's in school and the model's learning and it doesn't have a job yet. And then inference is like the model has a job. It has been trained as an accountant and it will now answer your tax questions, right? So now inference is when I show the model this and I go, what is it? And it says, that's a coffee mug. I say, what color is it? It says light blue. The model's been trained and it's spitting out answers, and that's the inference process. And the economics of those two processes are very different. I can't really charge you for training my model because you don't care, but I can charge you if you need a tool that identifies the items on my table, and I can get you to pay $2 a month for that. Well, now I can charge you for those inference queries, right? And that's more what we're getting to. But the analogy that I've moved to recently, everybody wants to compare it to railroads and the capital expenditures of railroads. It was different because training a model is like building a steam engine. It can go really, really fast, right? Building a steam engine was like expensive, but it wasn't the main expense of the railroad. The railroad expenses were laying the tracks to connect all the cities. Well, the economics here reversed. Building the steam engine, the model, is what's really expensive. Connecting it to do useful tasks is way, way cheaper, right? And so to take that useful steam engine / model and push it through the economy is going to happen much faster and be more cost effective than I think a lot of people think. And that's why I think people, when they look at telecom or railways, capital expenditures, I don't think those are good comparisons.
And the frontier of expenditure for result in using AI has shifted to this inference time, because to begin with, you had a trained model and you would ask it a question, you would get an answer instantly, you'd spend a penny. And now people are running queries that can take minutes, hours, longer. And clearly those are more expensive. They're burning through tokens, they're burning through dollars, and they're accomplishing much more complicated things that are more like a whole task, a series of questions put together in a sequence. And that makes me think that this is where businesses are going to try to compete to see who can spend the most. Because if it costs a significant amount of money to do something there, then whoever's got the most money might be able to beat someone who has less if it can buy them more inference. Do you think that's happening?
Yeah, I think a lot of companies that do have profitable AI businesses on the inference side, which there aren't many yet, but maybe somebody like Google, I think they're inference constrained at the moment. And so I think that's an issue. And it's not even that they don't have enough capital, it's that the supply chain can't absorb the level of capital that they really need to deploy it out at scale. They can't build these chips fast enough. You have to go build fabs from TSMC, and NVIDIA has to have a new design that gets fabricated there. And then those chips have to get made, and that takes a few weeks, and those have to get shipped here and deployed and set up in a data center, which has to get built. And so, yeah, it's a lot of stuff. But again, I think people are, NVIDIA acquired this company Grok, which has a much more efficient, what they call language processing unit. So for certain types of inference, the Grok chip can perform really, really well. For other types, it can't. It's not as general purpose as NVIDIA's existing chips. But I think you're going to see those deployed because building task-specific chips outside of digital signal processing hasn't been a very lucrative market over the last couple of decades, but that's changing.
How is the business landscape going to change here? We were talking earlier about how things are just getting faster in business, and the way in which we're using AI to compete is having these effects of burning people out faster. As you said, wow, I might have to wait a whole 30 seconds for the answer from this inference chain. That's too long.
Yeah.
Well, you didn't say that part, but you're looking at ways of speeding it up. So that's very different from the days when you would fire off a compilation and go and have coffee and come back half an hour later to be able to try the next result. This feels like a major sea change in business. And maybe the frontier of that is going to be in middleware, if that's the right way to call what you're doing at the moment. Can you make products that make that easier for businesses?
Yeah, I mean, if you think about it at a high level, part of what we're trying to do is OpenAI and Anthropic and a few other places have built this giant infrastructure that helps them train models that they can sell. And it's really expensive. Turns out you don't need to build frontier models to be able to do useful tasks. You can only lean on the frontier models when you need to. You can build models of other tasks, but still building those models, most companies don't have the infrastructure. Building the models, testing the models, managing and deploying multiple models or whatever. So if we can make that easy for small to mid-sized enterprises, a couple thousand, a couple tens of thousands of employees, that's a very valuable thing for them, I think, to not have the reliance. Like what nobody wants here is the Fortune 5000 do not want to be held feet to the fire to two companies, OpenAI and Anthropic, who provide all the models for them to do everything, and just they'll suck all the margin out of their business and have all the control and all that. So people are looking for data sovereignty and model sovereignty and privacy and things like that. And that's what we're hoping to give them.
Well, but then Microsoft and Google would have something to say about that as well. Do you feel that there is not enough choice at that level?
Yeah, I wouldn't even say it's not enough choice. I think it's AI is going to be such a big chunk of the economy. You just don't want one company to run that, right? The same reason that you wouldn't want one company to own all the world's real estate or most of the world's real estate. I think fragmentation is good. That's something that we're pushing for.
That is the end of the first half of the interview. Next half, next week. We keep these episodes around average commute time. At least I sympathize if your commute time is longer than an episode. In today's news, ripped from the headlines about AI, we got some insight into what AI is doing to the typical business job, and it ain't pretty. Yasmin Ahmad, managing director of Google Cloud, told Fortune magazine about big wins that companies are realizing from using AI to accelerate their workflows. This part is good news, at least for the companies. We're talking about shrinking process times by 2 orders of magnitude. But does this result in the 15-hour work week that John Maynard Keynes forecast that we would have by now? No, it just means that employers demand more out of those employees who are using AI, and this process of supervising AI tools results in 12% higher levels of mental fatigue, information overload, and decision fatigue, what researchers call AI brain fry. Descriptive. As the article says, the question isn't whether AI gives you back 6 hours, it's whether anyone lets you keep them. A quick reminder here to please give us 5 stars and a nice review. You've heard how every time a bell rings, an angel gets its wings. Well, every time you hit the like button, another 100 people hear about the podcast. And maybe some of them are angels. Don't know about that bit. The point is that we're doing important work here and more people would benefit from it if only they knew about it. But they're not going to find out about it from our full-page ad in the New York Times. That's where you and the like button come in. Next week, we'll conclude the interview with Rob May, when we'll talk about AI processing on local devices, natural limits to automation, the shift in competitive advantage from execution to creativity, and restructuring of the economy and the workforce. That's next week on AI and You. Until then, remember, no matter how much computers learn how to do, it's how we come together as humans that matters.
That's all for this episode of AI and You. Please leave a rating and comment and share with your friends. Get the book Artificial Intelligence and You and see more videos and articles at aiandyou.net. That's aiandyou.net, where you can also send us your questions. Thank you for listening.